In this video, we'll cover some tips on how to identify a chemical reaction type when looking at a chemical equation. Here are some of my tips. These are what I generally look for when I look at a chemical equation, and I am asked to classify that chemical equation as either a combustion, a synthesis, a decomposition, a single replacement, or a double replacement reaction. I'll quickly go through 10 examples here and refer to these bullets as they become relevant. Okay. For this first example, we have lead 2 chloride reacting with silver nitrate, and it's producing lead 2 nitrate and silver chloride. Since I know that these all involve ions because of the ionic compounds present, I know that this is a double replacement reaction, okay? And double replacement reactions always have two compounds that are made of ions, basically. Okay, so this is a double replacement reaction. Now we have what is ammonia reacting with hydrochloric acid, and it's producing ammonium chloride. Now for this reaction, I'm looking at the fact that there is only one product, so this is automatically a synthesis reaction. Synthesis reactions only have one product. For example 3, magnesium phosphate is reacting with hydrogen gas, and it's producing magnesium and phosphoric acid. Okay. For this reaction, since there is a single element or a pure element and a compound, which is multiple elements combined together, since there's a pure element and a compound on both sides of the equations, this is a single replacement reaction. On the left-hand side of this example, we've got our reactant aluminum oxide, and this one is producing aluminum and oxygen gas. For this reaction, I am noticing right away that there's only one reactant. You're only starting off with one thing, and it's breaking into two things. So since we're only starting with one reactant, this is automatically a decomposition reaction. All right, we're halfway there. We have what appears to be, on the left-hand side, hydrocarbon, and it's reacting with oxygen gas. It's producing carbon dioxide and water, okay? Now, when I see this, the fact that it has a hydrocarbon reacting with oxygen gas, this already makes it a combustion reaction. And the fact that it's also producing carbon dioxide and water is further verified because all combustion reactions produce carbon dioxide and water only. Example 6, we have here zinc metal, and it's reacting with sulfur, pure sulfur, and it's producing zinc sulfide. Dead giveaway, there's only one product here, so this is a synthesis reaction. Two things are combining to form one thing. It's synthesizing. For example 7, we have sulfuric acid reacting with iron metal. Now it's producing hydrogen gas and iron to sulfate. Okay, now for this reaction, I'm noticing on both sides of the equations, the reactant and the product side, that there is a compound and a pure element. So that means this is a single replacement reaction. Now we have, on the left-hand side, just ammonium nitrate, just one reactant. And this one is producing dinitrogen monoxide and water, all right? Now, since there is only one reactant and it's breaking apart to form two different products, this is a decomposing reaction or a decomposition reaction. For this reaction here, we have sodium sulfate reacting with aluminum chloride, and it's producing aluminum sulfate and sodium chloride. Now this one involves ions because these are ionic compounds, okay, both sides. So if they are all ions, this is a double replacement reaction where all of the ions are swapping places. Here's our last example, example 10. Now we have on the left-hand side a hydrocarbon because it has carbon and hydrogen, and it's reacting with oxygen gas. Now it's producing water and carbon dioxide, which is always characteristic of a combustion reaction. Okay, combustion reactions always have a hydrocarbon reacting with oxygen gas, and it always produces carbon dioxide and water. Okay, now it's your moment to try just 4 examples here. So pause this video, okay, actually pause it and try it, then take a look if you've got it correct. And here are the classifications. You can use the guideline on the left-hand side to further narrow it down if you'd like. But for the purposes of this video, we're just going to classify generally what type of reaction it is, not the very specific ones. Okay. And I have more examples for you to try. I actually want you to try it to see if you can actually classify the type of reaction based on what the chemical equation looks like.